Hi, and welcome to another PIADA YouTube tutorial. My name is Olivier, and I'm the stake pool operator of SBLYR pool. And today we will be showing you how to create an NFT collection on the Cardano blockchain. If you haven't watched our first video yet, make sure to watch that video. It's in the corner of this video. Now let's go ahead and start our tutorial. Don't forget to like, subscribe, and hit the notification bell so you will be notified when we put out more videos in the future. Also, don't forget to look at our website, ada-pi.io, or join our Discord channel. Okay, so if you haven't watched the previous video, let's begin with cloning the repository. So let's git clone https://github.com/ada-pi/Cardano minter, and let's just check it out to the minter directory. Okay, once we've done that, we go inside the directory, and let's begin by installing some additional dependencies that we will be using. In this case, it will be npm install form data.env axios low-sharp promise parallel throttle. And you will see in the next scripts that we'll be making how we are going to use those dependencies. Let's wait a bit for them to install. Okay, let's first start off by adding a new script that will be responsible for generating a assets.json that will contain all the metadata for the NFTs that we will be minting. So let's go call this create initial assets.json.js. This script is responsible for generating the initial assets.json that can later be adjusted to fit your specific needs, and it will allow you to define the amount of assets that you will be generating, whether you want to start the collection with either 1 or 0. So we'll be generating a list of NFTs, but you can choose to start the list off with 0 or 1. We will be adding those numbers in the names. You can always change that to your liking. And we will be able to define what the mine type of the source as well as the thumbnail will be. In this case, we will be just focusing on images, but that could be any type of file, really. What the mine type is, JPEG, PNG, or a GIF. A GIF is also possible. Okay, let's go ahead and import times from Lodash. We'll be using to generate an array of numbers. And let's import the file system functions as well. In this case, the promises version, which will enable us to use it in a promise-based way instead of using callbacks. Okay, let's define the variables that you can change to your liking. So that will be like the amount of assets, like we said. In our case, it will be 14. Whether we are going to start with 0 or not. In this case, it will be true. And let's define the mine type, which in our case will be image //png. Okay, now let's define a async function that will directly call, since we won't be able to use async in the top level scope. That's because this is common.js. And let's generate an array of assets by using promise all, which will execute promises in parallel. But I'm thinking about this, and I think that's not really necessary. So we can just use times directly, times the amount of assets. This will generate a list of numbers from 0 to 13 in this case, being 14 numbers. And if we map over it, we'll, as a first argument, we'll receive the index. That will allow us to create the asset with the appropriate number. So the number is going to be dependent whether we're starting off with 0 or not. So let's start with 0. It will be the number 0. Either we'll add 1 ending up with 1. Then we'll define the ID of the asset. That will in this case be PIADA, and then the number. So that will be PIADA 0. Then what we want to do is we want to get the extension of the image. We can do that by splitting this into an array, then reversing the array and fetching PNG from it. So we'll do that like this. MIME type split / reverse to an array, reverse, and then get the first element of the array, being the extension, PNG. And then we return the actual asset object, being the ID, and the name, which will be different. That will be the display name, as shown in, for example, pool PM. This will be the display name of the asset. So that's different than the ID of the asset. The ID will eventually be used to create the ID together with the policy ID. And that name is not allowed to have any white space characters in it. So that's why we put this together like PIADA 0. So in the name we'll actually be adding a space and then a hashtag, and then we'll put the number in. So you could also define a description. That's part of the metadata standard for NFTs that's now being created. But in our case, we will not be defining a description. So if you would like to do that, you can just go ahead and enter a description. Next up, we'll define the image. And what we will be doing in this case is define the location of the image that we will be uploading to IPFS using another script. So what I like you to do is to create a directory called images and put the images that you would like to create your NFTs with in there based on the name that we will be generating. You can adjust that later as well. And after this script, we will create a script that will download some random images from the internet. If you have no images at this time and you just want to test the script first, but if you have your own images, go ahead. We'll show that example as well instead of the images that we will be downloading. In any case, so this should be images / the ID. So it will be PIADA 0 dot or underscore thumbnail, because the image will contain the reference to the thumbnail of the image. So for example, if you would create an NFT based on a video or another type of resource that a thumbnail can be generated, you'll put the reference to the thumbnail here first, and you will put the reference to the original document or file in the src property. So let's add the extension as well, .png. So in this case, this will turn out to be images / PIADA 0 thumbnail.png. And for the actual source, we want to be using the name without thumbnail. So there will just be the same as this, but then without the thumbnail. Okay, next up, we still need to define the MIME type that we defined above. You can pass that. And you can add whatever you like below. So if you want to add other properties, you can add them as well. In this case, we will be adding the authors, PIADA, and SBLYR. And don't forget to delegate. That would be amazing. And then we will be defining the website, in this case, adapi.io. So now we have actually created a list of assets with an incremental number, and we already defined the references to where our images will be. So let's go ahead and write these assets to a JSON file. So we do that by writing await, because this is a promise, write file system write file, dir name plus assets.json. So the current directory where we will be executing this script from, or actually where this script is residing, that's the dir name, plus assets.json, and then we JSON stringify our assets. Now let's go ahead and try to execute the script. Initial assets.json.js, and you will see here that the assets.json has been created, starting off with PIADA 0, a reference to our files, until PIADA 13 being the 14th asset in this list. Okay, next up, we'll be creating a script that will download some test images for us. Okay, now let's go ahead and create a new script called download test images.js. And this script expects the assets.json to exist inside the src directory. There should be a reference to a file path on the local file system relative to the src there. What I mean by that is that the images being referenced in the assets.json should be relative to the directory that the assets.json is in. So in this case, images, the images directory. Now let's go ahead and import random from Lodash and Axios, as well as file system again. And then let's import our assets.json. In Node.js, you can just do that by requiring the JSON file, and then you will receive it as actual JS object. Let's define another asynchronous function that will execute directly so that we can write some asynchronous code. Let's use promise.all to execute those promises that we will be creating now in parallel. So we'll iterate over the assets, and then for each asset we will fetching an image. So Axios request, or you could say get https source.unsplash.com / our dimensions that we will be fetching. So source.unsplash.com will allow us to download some random images of a specific type. In this case, we will just be downloading some cat pictures. And let's also pass a random number so that we will actually get different cat images and not a cached version. It's important to specify the response type of array buffer. So we'll receive a buffer in our response object. Let's console.log whenever we get the asset. When it's done downloading. Okay, and then let's write this actual picture of a cat to the file system. So they will be in the current directory /asset.src. So that will be referencing to this. Let's write this data. And then once it's done, we can say image has been saved to image.src. And there you have it, a script that will download a list of random images and then writes them to the appropriate file name. So let's try and execute the script. And you'll see that something goes wrong here. Images is not defined. This should be asset. Let's execute it again. And you will see that we now have downloaded 14 cat pictures. That looks like a cat to me. So now that we have this list of images, let's generate our thumbnails. Okay, so the next script we will be creating is generate thumbnail script. In this script we'll require file system again and require the sharp module. The sharp module allows us to generate a thumbnail image based on another image. So let's actually define a function that will generate the thumbnail for us. So it's going to be called generate thumbnail. It will take the file path where the thumbnail image will go and the buffer of the image that we'll be using as the input. It will be sharp data resize. In this case, we'll resize it to 200. What it will do is, in this case, our image is 640 by let's see, 400, and it will reduce the largest of the two, of either the height and the width, to 200. So that will be 640 to 200, and then it will adjust the 400 in ratio. So let's output the resized file to the file path, and actually turn this into a promise. Okay, so we now have a function that returns a promise that will generate a thumbnail based on the data that we pass to it, and it will save it to the file path that we pass to it. Okay, let's import our assets again, so we can actually read the locations that we will be using to generate thumbnails for. Let's define an async function again that will immediately execute. Promise.all. We'll go iterate over the list of assets again. And then let's read the file from the file system. In this case, our source image. We will receive the buffer of this image, and then we will generate the thumbnail with the function that we just made. Their name plus asset.image. Remember that this is referring to the thumbnail location. And we will pass the buffer to it. And then once we generated the thumbnail, let's just output something to the standard out, so that we know the thumbnail has been generated. Okay, let's see if we can generate some thumbnails for our cats. Node src generate thumbnails, and there you have it, our cat, and a small version of our cat. So now that we have our images, either you download the images using the script we just made, or you have your own images, we have to upload them to IPFS and pin them to a certain node in order for the images to maintain on the IPFS network. So IPFS is a solution that we use to store the image or other type of file of our NFT in a permanent way that we will be referencing from our native asset metadata. And you can use some services to do this for you. In this case, we did some research and found about blockfrost.io. They have a solution for that. So you can use the add endpoint for IPFS to add a file to IPFS, as well as pin your specific file to their nodes. But we also found another service called PIADA.cloud, and that seemed to work pretty well. And what we now do is go ahead and generate some API keys. So these API keys we'll be using in the script to upload those images to IPFS. So let's go ahead and create a new key. And in this case, we will be only using the pin file to IPFS call. Let's name it YouTube video. Okay. Let's copy our API key. And then let's create a file called .env. And here we will specify our environment variables, which should not be committed to your repo. In this case, the key will name PIADA API key, as well as the PIADA secret, API secret. Okay, now let's go ahead and actually create a function that will help us pin the file to IPFS using PIADA. So pin to IPFS.js. Then let's require .env. .env.config will find any file that's in the same directory as this script with the extension .env and load those variables as environment variables. That's where this module is for. Then next, import Axios, as well as form data and a file system again. Okay, then let's create a Axios instance specific for PIADA. Axios create, base URL. It's going to be https://API PIADA.cloud. And then we are going to specify some headers. In this case, the PIADA API key, process env PIADA API key. PIADA secret API key. PIADA API secret. So these headers will then authenticate each request that we do to PIADA. In this case, only pin file to IPFS. Let's export this as a function that we can use in another script that we'll be creating next. We will take the name, the file path, then let data is new form data. We create a new form data object. Then we append the file to it. We'll create a read stream. For the file path. We can define some metadata as well. When we pin it to IPFS, in this case this will be the name that we pass. Then let's append this metadata to the form data object as well. PIADA metadata. Okay. Let's define PIADA options. So what we do specify here is the regions in which these files will be pinned. So PIADA Cloud has multiple nodes running at different locations, and we will be defining at which regions this file will be pinned with a SID version of 0, custom pin policy, first one being in France. If you want to adjust these settings, you can just go ahead and look at the documentation of PIADA Cloud. Okay, once we define these options, we also pass these options to the form data object. Okay, and then let's go ahead and create a request that will actually pass this form data and pin the file to IPFS. /pinning/pin file to IPFS. We pass the data, and then we specify max body length of infinity. And this is needed to prevent Axios from erroring out with large files. And then we specify the headers, the content type being multi-part form data, and the boundary we can get from the data. And then let's do some error checking, because I used this before, and once you use it too quickly, when you're doing too many requests too quickly one after another, it can be a little bit less stable. So it's good to log some errors in case. If you get any errors, let us know. We can help you out. So if there's a response inside of the error object, that means that the server responded with something. We can then respond the error. That's what happened with me in this case. Otherwise, we'll just log the error message if that's not the case. Okay. Then once it's successful, we actually get a hash back from the API that's referring to our file on IPFS. So IPFS works in the way that if you upload the same image multiple times, you always get the same hash back. So in this case, the hash will be contained in response.data.ipfs hash. And then in our nice little function, let's just return the hash as returned by the API. But also, let's already define a IPFS link that can be opened in the browser if you have IPFS installed on your local machine. We'll pass the hash to that. And let's also just generate a HTTP link that can be clicked. So if you don't have IPFS installed on your machine, you can always use ipfs.io /IPFS and then your hash. So now that we've created this function, let's actually create a function that will run through our asset list, and then for each image as well as the thumbnail that is on the file system, let's pin those images to IPFS. Let's go ahead and create a new file called pin images to IPFS.js. let's import our file system functions, the promises based one, pin to IPFS function that we just created, and then include throttle. Now what throttle will do is, throttle is similar to promise.all, but where promise.all will execute each promise in parallel, throttle will actually execute them synchronously with the amount that you specify. So you can actually limit throttle the amount of promises that will be executed in parallel. You could also just use a for loop and then make it parallel in that way, but throttle will allow you to specify a specific number that is allowed to be executed in parallel. It's a nice little utility function that I use all the time. Let's also import our assets again, so we can iterate over that list. And let's specify our main function again. Main. So in this case, we will return an updated list of assets, because what we will do is once we've run through all the images and pinned them to IPFS, we will be updating the reference to the image. In this case, images / PIADA 0 thumbnail.png. We'll replace it with the IPFS link, as we will be using this list of assets to create the metadata to do our mint transaction. This is perhaps not optimal, but for the sake of this tutorial, it's nice that we just automatically replace these locations once we have uploaded those images to IPFS and we know that they are on there. So let's do await throttle.sync and then iterate map over our assets. And what's a big difference between promise.all, where you iterate over the assets? What you usually do is create the promise right there. But once you iterate over the assets, it will be directly creating the promise and also be executing it. And that's not what you want. What you want is for the throttle sync function to not pass an array of active promises, but an array of promise creators. So functions that return new promises. So that will look like this. You'll create an arrow function within an arrow function. In this case, it will look like this. So we have the asset. It will return an async function that throttle then can call in sync instead of those promises already being executed. So what we will do is upload our thumbnail image to IPFS. So what we'll return is an IPFS link, like we returned from that function, that we'll call image, and the HTTP link that we will call image link. And we'll call pin to IPFS, use our asset ID to create our file path. I'm sorry, to specify the name on which we will be uploading this file to IPFS. In this case, we will call it asset ID, so PIADA 0_image. And then we will specify the path, the file path that should be used to upload. And it will be asset image. So we'll pin the thumbnail image to IPFS, and then we will get the the image reference, IPFS reference back, and the image link. And then let's console log once this is done, so we actually know when it happened. Pinned image to IPFS, image link, right? And now just copy this line for our original image, so the SRC image, and call it SRC and SRC link. And then just also console log this. And then return our updated asset. So we'll just spread out all the properties from asset into a new object, and then add our updated image and SRC properties to it as returned from these functions. So what that will do is what I said, like it will generate a list with the updated references to the images on IPFS. And let's go ahead and write these updated assets to assets.json. Await file system write file, their name plus assets.json, JSON stringify, updated assets. And let's confirm it back and say written updates to assets.json. Okay, now that we have this, we have defined our API keys. We've created a function to upload the image to IPFS and pin it. And we created a function that will go through all our assets and use that function. Now let's go ahead and actually pin these images to IPFS by executing it. And then we get an error that says data of undefined. Let's go ahead and take a look. So it could not find the .n file because it said here that the value for header PIADA API key was undefined. That means that this could not be found. It means that this didn't work, and that's because we put the n file in the wrong directory. We should put it on top. So it will not be looking in the directory that this script is coming from, but it will look in the directory from which we execute this script. So in this case, we should be able to run it again. And there you see it's now slowly pinning each file to IPFS one at a time. Let's go ahead and wait until this script is done. So let's check this actual image out on IPFS. And you see the images uploaded to IPFS, as well as our assets.json is now updated with all the references to the right images. So now that we actually have all the metadata as well as the images pinned to IPFS, we can go ahead and mint the NFTs. Last time in our previous video, we used a open policy. That means that we created a policy ID that we could use to mint our NFTs. And we could, for example, in the future, use that same policy ID to burn the same tokens again or mint new tokens in the future. In some cases, for example, with an NFT collection, you actually want to put a limit, a specific time until when you can create new tokens, mint new tokens, and burn tokens, and actually put a limit on that so that in the future, the people who buy those NFTs from you can be sure that you won't be creating any more NFTs or burning some NFTs. So let's go ahead and create a script where we will create the minting policy just like we did in the previous video. So let's call it create mint policy script. And then let's import the file system functions. Import our Cardano client. And then let's get the wallet. In the wallet, we will be needing to actually create a hash of our address that's unique to our wallet. So let's define the mint script. So the open policy, just like we did last time, will look like Cardano.address key hash based on our wallet name. And we will have a type of sig or signature. And then let's go ahead and write file sync. Output this mint script as a JSON file. Mint policy.json. Mint script. And then let's also create a mint policy ID.txt where we will be creating a hash, generating a hash based on this mint script. So it will be Cardano.transaction policy ID mint script. Okay, so make sure that you have your wallet created. So you can use the create wallet function for that. So there can be node src create wallet. In our case, we already created the wallet, so don't execute this because that will override your original payment address. It's pretty dangerous if you put a lot of money in there. Don't do that. Okay, so to verify our wallet, let's just do get balance. And then you'll see we have some 23 ADA in there. Okay, now just go ahead and re-execute our create mint script. Create mint policy.js. This now will output our mint policy.json. So this is the hash based on our wallet, as well as our mint policy ID generated from this mint policy.json. It's called the mint script. Now let's copy the create mint policy and make it a time locked based mint policy. So the time locked mint policy will kind of look like this. We'll create a object with a type of all, meaning all signatures should apply. Where we'll define a slot. So we'll actually define a before. So before a specific slot, you will be allowed to mint or burn any assets. That will be the slot that we can fetch from Cardano, creative. And then a slot at this moment will be increasing every second, but that can change in the future. But let's just define what the slots right now look like per epoch. An epoch in Cardano is 5 days. So that's 5 times 24 hours times 60 minutes times 60 seconds. And that will leave us with 5 times 24 times 60 times 60, 432,000. So that will be 432,000 slots per epoch. And let's take the current slot and then add an equivalent of 5 epochs of slots to it. So that means that we will have 5 epochs to mint or burn our assets. That should be enough in my case, but you can adjust it the way you would like to adjust it. Okay, let's just copy what we did originally. So what we actually did is we split out the mint script into multiple scripts, and we said that it need to. So this is basically the conditions at which the script should be checked, and you can make this, for example, any or at least, or you can look that up on the Cardano minting documentation, minting policy documentation. But in this case, it means that it should validate for this as well as this at the same time. And you could, for example, also require other wallets to sign when you mint or burn a token by just adding new address key hashes. But when you execute the mint transaction, you should let those addresses also sign the transaction. Otherwise, it won't work. That's the whole purpose of this mint script. So you could, for example, make multiple people responsible for minting and burning the tokens. Or you could say at least 3 of the 5 people should sign when minting this transaction, when doing the minting transaction. Okay, so let's go ahead and actually execute this and see what this looks like. And then we will see that our slot number has been outputted, as well as the key hash again, same as before. But our policy ID now will be looking different based on the other underlying scripts. So whenever you generate the policy ID based on the mint script, you will always have the same policy being outputted. But if you were to increase this time to another value, this policy ID would of course change. That's why the policy ID in this case is pretty unique to this scenario. So you can make sure in the future nobody will be able to create another minting policy that will look like this. Okay, now the next step is to actually build our mint transaction. Let's create a function that will make it easy for us to both get our policy ID as well as our mint script. Get policy ID Cardano. Let's import our mint script from the disk. Mint policy JSON. And then let's export this as a function that can be called by other scripts that will return our mint script as well as the policy ID. And in this case, just create the policy ID again by generating the policy ID, transaction policy ID, based on our mint script. Let's create a script that will mint our assets called mint multiple assets. Okay, let's import Cardano as well as our get policy ID function that we just created. Import our assets.json containing all the metadata that we are going to use to create the mint transaction. Then let's get the wallet. Okay, let's get the actual policy ID and turn it into a constant, as well as the mint script by executing get policy ID. Then let's generate the metadata based on our assets, using our assets. What we will do is reduce. That's the same as map, but it will allow us to return a different object or array with a different length that looks different than the original array. Let's define a constant called asset ID that is based on the policy ID plus the dot plus the asset ID. So that will be policy ID dot PIADA 0 in this case, and for every other asset as well. Then what we need to do is remove the property ID because we don't really want to include that into the metadata. But instead of removing it from the original object, let's create a new object which we'll be removing it from. So we call that asset metadata. We spread out all the properties that we defined in the asset in this object. So it will contain all those properties. That's enough to copy the object, but that will allow us to delete the ID. And then let's return the object with the asset ID and the asset metadata. So this will be the object containing the metadata for our NFTs. Let's output this to show you what it means. Here you can see we generated a list using the policy ID and the ID of the asset with the name and all the other metadata for the NFTs. Okay, then next define the actual metadata that we will be sending alongside the transaction. First specifying the label of the asset that we will be using, in this case 721, referring to the ERC 721 standard. Then we add another scope where we put our metadata inside a property with our with our policy ID, and in that object we'll finally put our metadata assets. So to let you know what it looks like, that looks like this: 721 policy ID and all the objects. Okay, next we will define what the TX out will be for the payment wallet, because we will be minting the assets using a transaction to our own wallet. In this case, we will reduce again. And in the output will be the balance that's currently in the wallet. That's currently just some Lovelace and no other tokens. And then let's add the expected outputs based on our assets. So that will be define asset ID again, using the policy ID concatenated with the asset ID using a dot. Specify property using our asset ID with a value of 1. That's going to be the supply of our asset. And return this result. And that in turn will look like this. Made a mistake there. Needs to be assets. And then you will see that the amount of Lovelace that will be in the output is what is inside our wallet right now, plus all the expected NFTs. And then when we do the minting transaction, we also need to pass some mint params, specifying the amount of the NFTs that we want to create with the asset ID, so the token ID, this here. Let's create those as well. It's called mint actions, assets map. With an amount of 1, token is policy ID plus dot asset ID, and these mint actions will look like this. So you see, for every token we do an action of mint with the amount of 1. Now let's put this all together in our transaction. So the transaction in will be our wallet balance dot UTXO. So that's this right here. And then our transaction out will be our address with the amount that we just generated here. And we also specify our mint actions, our metadata, and the witness count of 2. And then let's create a script that will mint our transaction. We can copy that over from here. So that's the build transaction until sign and submit. Let's paste it in here. And let's execute this. To see if our tokens will be created. As you can see, the transaction has succeeded. Let's wait a while and check our balance. The tokens are not there yet. Now you can see our tokens are there. Now the next step is to actually send our assets back to the wallet. Let's go ahead and make a script for that. Last thing we need to do is send back our tokens to our wallet. So let's create a script called send multiple assets back to wallet. Let's import Cardano. Let's get the assets.json, get the policy ID, get the wallet, let's log the balance, let's get the policy ID, and let's define a function that's called send assets for a specific address, as well as the IDs for the assets needed to be sent. Okay, so now that the wallet contains these assets, let's say you want to select a few assets and you want to send them to a specific wallet, we want to generate the right outputs for the sender wallet as well as the receiver wallet. So we will allow you to specify the IDs of the assets that you want to be sending, and then we will define the output, which NFTs that still need to be kept in the sender wallet, as well as we will define which tokens will end up in the receiver wallet, the output for that. So let's define the outputs, tx out for this sender. Assets reduce result asset. Specify the asset ID. In this case, the asset won't be the object, but the asset ID. Let's delete from the result the asset ID, because we will be sending this asset. So imagine this list, and then every asset that we specify to be sent will be deleted from this object, and that object will be returned. So that will be the new output for the sender wallet. Let's do the same for the receiver wallet. And in this case, the amount will be 1. So we'll just be replicating the key value as specified here. And in this case, we start off our reduce function with an empty object. Okay, so we have both the output for the sender as well as the receiver. Now, whenever you're sending assets to another wallet, you need to send a minimum amount of ADA. This can fluctuate. So in the last tutorial, we had 1.5 ADA. That was enough. But we tried to do it again this time, and 1.5 wasn't enough. So we increased it to 1.6 ADA, and that worked. But basically, if you don't have enough ADA that you're sending at minimum, you will get an error. So this is dependent on the network at the time that you're doing this. And try to increase this amount of ADA if you get an error saying output too small UTXO. So once you try to submit the transaction with a too low amount of ADA, you will get this error. So if you get that error, increase this number. Okay, let's define our transaction. TXIN will be our Cardano query UTXO, sender payment address, TXOut will be for the sender the amount as we generated, TX amount sender, and then we will deduct some Lovelace. So how much is in it? Minus Cardano to Lovelace, min Lovelace. Actually, this should not be called min Lovelace, but min ADA, because we are converting it to Lovelace here. Okay. Now let's define the output for our receiver. The amount of Lovelace being the amount which we are going to send, min ADA, and our output as generated for the receiver. So now that we have this transaction info, let's just build a transaction. Cardano transaction build raw, tx info, and calculate the fee. Let's deduct the amount of Lovelace for the fee. Once transaction is Cardano transaction build raw tx info with the fee. Now let's go ahead and sign the transaction. In this case, a signing key for sender address, payment address. TX hash, Cardano, transaction submit. And let's go ahead and log TX hash. And let's get our payment address to which we want to send our assets. So we'll say send assets for the receiver. That will be our payment address, and then which assets we want to send. In this case, PIADA 0, PIADA 1 and 2. The other ones, in this case, I don't want to be sending, to give you an example. But what you, for example, could also do is say assets from our assets. If you want to send all the assets at once, you just generate a list of IDs based on our assets JSON. And that way you will be sending all the assets to that wallet. So let's go ahead and get our receiving address. And execute the script. Something went wrong. It looks like the amount of ADA that we are sending along is too small. So let's increase this number to 1.7 to check. And you see that the transaction actually worked. So this is good that this happened, so you can actually see it happen as well. And now let's wait in our wallet to see if the tokens will arrive. In the meantime, we can also use this transaction ID and put it into Cardano scan. And you can see the transaction hasn't been processed yet. It will take a while. Let's try it again. It's not there yet. And there you see, we got our outputs. And you see that the 0, 1, and 2 we send to the wallet address that we specified, and the others arrived at the same wallet. So let's take a look. at our PIADA 0. And our mint transaction. And then you can see that we minted all these assets at once. And our metadata contains all the information to all the other images. So for example, if we were to open this, we should be able to get our image. And you see it works. And let's also view this in full PM. For our wallet address, there you see that we have the berry space green from our previous tutorial, as well as our newly created NFTs. But the images as well as the naming should still update in some time. Thanks for watching, and make sure to delegate to the pools of Berry, PIADA and SBLYR. The links are in the description. And if you would like to find out more about this project and speak with us, please contact us. And stay tuned, and we will see you at the next video.